Hello everyone, welcome to the session. So now in this video, we'll continue our previous discussion where if you remember, we have normalized our data of training and the testing set into some range. And the reason behind that is because we have seen that population is one feature that we have in this house price prediction data set, which can create a bias when we are doing a model prediction or when we are training our model, right? In order to avoid that, what we have done is with the help of a standard scaler, we have tried to normalize our data points in the training set as well as in the test set. And if you remember, I have given you one assignment or you can say homework to explore on your own that when we are doing the normalization part in the training set, I have used a function named fit underscore transform. Whereas in the test set, when I was doing normalization of the values of a given feature names that we have, I have used the function named transform. And I told you that in an interview, interviewer can ask from you that why usually this will happen. Why in the training set we are using fit underscore transform function, whereas in the test set we're using a transform function. What could be the possible reason behind the same? So now I hope that you already have explored and you already have something in your head before I will give you the explanation. Let's try to understand this point very clearly and then we will move ahead in the next upcoming part of a model training phase. So what usually happens? I talked about a standard scalar, right? So we have applied here standard scalar in order to scale our values. Standard scalar. And in the last session, I have done the implementation. I hope you have clearly seen that and you know that how we can do so. Now, what usually happens, I told you in the last video itself that, basically it tries to give us a data in the normalized manner, or you can say in the standard normal form. Instead of writing normalized manner, I should write standard normal form. Now, if you have a clear cut idea about the concepts of statistics, you will be clearly aware about the idea of a standard normal form. Standard normal form meaning that we will be having a mean value as 0 and standard deviation value as 1, right? This is the meaning of a standard normal form. The question is how we can convert given data points. If I'll provide you a set of feature values, numeric data points, if I'll say how will you able to convert that into a standard normal form, what will be the formula to do that? So the answer would be it will be done by the z-score. So it will be nothing but what is the value of xi minus mu by sigma. Means anyhow what you supposed to do is you need to compute. This is something which is nothing but mean, and this is something which you can say is the standard deviation, right? Standard deviation. So what does that mean? For a given set of feature values, first of all you need to compute the value of a mean as well as the value of a standard deviation. Now for every feature that you have, maybe you have number of bedrooms, you have average number of bedrooms, you have so many features, right? So basically what you usually do is you will try to get that value of a mean and the standard deviation for every particular feature which we are considering to go into the training phase. Now what we will do is this is something which we called it as a fit. So what is the meaning of a fit? When you are saying that in the training set you are applying a function named fit underscore transform. That is the question, right? In the training set, when we are doing a standardization, we are applying a function named fit underscore transform. The question is what this function is doing. This function is composed of two tasks, fitting and then transforming. So when we are saying we are fitting our model, means you are trying to compute the value of for every feature that you have. What you are doing is you are trying to compute the value of mu and sigma. You are trying to compute the value of mu and sigma. And then when you are saying transform, what does that mean? The simple meaning is you are trying to transform all the given values by applying that formula, z formula, right? So here you will try to do the get the normalized values by applying that z value formula, right? Which needs the value of mu and sigma. I hope you will be able to understand. So now that's why in the training set we are doing fit and transform. Whereas when we are talking about a test set, what we are doing, because now in the training set we have already the values of mu and sigma for every feature value that we have. That same value we will try to apply, and we will just do the transformation. Means we will just do the finding of that z value with that mu and sigma, because we don't want to change the properties of a test set, and that is very important to understand. So that is the only reason that why in the training set you will always observe in machine learning we are applying fit underscore transform while doing the standardization, and in the test set we're only using a transform function. That is the only reason. I hope now you will be able to understand that part pretty well, and you will be able to explain the same thing to the interviewer as well, right? Now let's move ahead to the next important part, where the next important phase which we are starting is the model training, right? Now what model we want to apply is a linear regression. So let's start with the next phase, which is a model training, which we want to do. Here what we will do is, first of all, obviously we need to import that model. So what we can do is we will try to import our model, which is available in linear underscore model. So what we can do, we can say from sklearn dot linear underscore model, we can import model name linear regression. After that, what you will do, you will apply this linear regression method, right? And then what you can do is you can fit your training set, that normalized values, into this. Now what you can do is you can say regression dot fit, and here you can pass your xtrain norm values that you have, and the ytrain data, which is corresponding to every data point that you have the final actual predicted value. One important thing is, as of now, if you will be able to observe, we have not removed any of the feature value, right? But when you will be doing this task, please make sure that it would be great if you can remove any one feature out of this F room and F bedrooms, because they will be having a higher correlation coefficient. Try to see the performance. I am doing this by considering all the metrics, so you will be able to see the performance of the model here only in the sessions itself. Then what you can do, when you are doing this task, try to remove, drop any one of the feature, maybe F room and average number of bedrooms. Similarly, out of this latitude and longitude, any one of them you can try to remove. As of now, we are considering every feature, but it would be great, I believe, that if at your side, what you can do is you can try to remove the features which are having a high correlation coefficient that we have seen. Average bedrooms, maybe you can remove, and longitude part that you can remove. Okay? So let's try to fit our model now. Let's do this. So this is done. Now what we can do is we can see the coefficients that we have in the regression model that we have. So what you can do is you can say print regression dot coefficient, and here if you will be able to see, you will be able to get the values of the coefficient of the regression. So what is this all about? If you will be able to see how many values you will be able to get, it will be 1, 2, 3, 4, 5, 6, 7, 8. Why is that so? I hope you will be able to understand this point very clearly, because here if you will be able to observe, we will be having 8 features, right? So how the equation of that straight line will look like in a linear regression? Obviously, when I was doing the explanation, I have talked about y is equals to mx plus c, right? Considering that we have only single feature, but in practical real-time scenarios, obviously we will be having multiple features, right? So the equation will look like, because we will be having 8 features, it will look like m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus m5 x5 plus m6 x6 plus m7 x7 plus m8 x8 plus c. So here if you will be able to observe how many independent features we have, 1, 2, 3, 4, 5, 6, 7 and 8. So in a way we will be having 8 independent features, right? So corresponding to every feature, I have taken obviously the values. So this is a coefficient. So when we are saying we are trying to evaluate the coefficient values, it means what we are getting in that list. So what we are getting in that list is something which is the value of m1, m2, m3, m4, m5, m6, m7 and m8. This is what you are calling it as a coefficients of the regression model that you have. It is what you will be able to get in that code part, right? Okay, this is something that we call as a intercept. I hope again everyone knows this part as well. This is what we call as an intercept, and all these things are the coefficients. Coefficients, right? So what I can do is I will try to show you the intercept as well. It means intercept will always remain the one, but the number of coefficients will depend on the number of features that we are looking into, or the features that we have in a given data set, right? So let's say if you will remove the features which are having a higher correlation coefficient, and by removing that, let's say you are having only 6 features currently when you are training your model, then obviously when you are trying to get that coefficient value, you will be able to get 6 different values of m1, m2, m3, m4, m5, and m6. I hope my point is clearly understandable to each and every one here. So what we can do here is we can try to print the values of now, what we can say, intercept. So what we can say, regression dot intercept underscore. So once I will do this, you will be able to see, we will be able to get the values of the intercept now, right? I hope it is clearly visible to each and every one. So this is all about the model training, which is done. Now in the next upcoming session, we will try to see how we can do the model prediction. Okay? We will try to see how we will be able to predict our data, means the price of the house, given the testing set that we have, right? We have split our data into training and testing. So on the training set, we already have created our model by the name of a regression, which you can see here. We have trained it pretty well. We got the coefficients values, we got the intercept values. Then now the next important phase is to check the model predictions, that whatever model we will be able to get, whether this model will be able to give us the predicted price value or not. That is what we need to see. So stay tuned. I'll see you all very soon in the upcoming video, where now we will see how we will be able to get the predictions out of this model. Bye bye everyone, and see ya.